All right, good morning, everyone, again. So we are going to talk about some of the assignments related to Khan Academy that I posted in the weekly overview. So do me a favor, grab some paper, grab something to write with. We're going to go through some notes, okay, that relates to those assignments directly, and you get through the assignment and then you'll be done with the Khan Academy portion of it. Okay, there's just the other note taking portion that I want you to do, that I want you to watch. Okay, the videos from Khan Academy and then submit those. Okay. All right, so let's take a look at it. So I'm going to do a present screen. Let me see here. Okay, so you guys should be seeing my screen right now. And I'm just going into Google Classroom. This is what I see as a teacher. I can't imagine you guys seeing something that differently, okay? But what I'm going to do is I'm going to go into the weekly overview over here, which is this guy right down here. And here I describe again what the this week's learning target is, okay? Which is we are going to be talking about circles and circle geometry. I posted a message to you guys. Hopefully people have seen that, okay? Basically, again, just talks about we are entering into a new unit, and that, that I'm really proud of you guys, okay, for attending office hours and also for just, acquiring and learning the material on your own. I'm so proud of you all. So I want to click on this. This is the weekly overview. In yesterday's office hours, okay, we went over, I told you guys to that you had to watch this, which those who were in office hours on that day, you guys were there and you guys took the notes of, and you guys were to submit the notes in Google Classroom. The second thing that we did was this thing right here, which was a Google form, which everyone here has done. So now we're moving into the circle geometry portion right here. So in addition to the office hours, I'd like you guys, at the end of this, just go and watch this on your own and take notes on it, and submit those in Google Classroom. What we are going to do, okay, we are going to go directly to exercise, which are these things here, which is arc measure. Okay, we're going to go into that. Okay, so I'm going to go into Khan Academy, and you should open up Khan Academy too.
Can you do
okay? And what we're gonna do, okay, and within Khan Academy, these are all the assignments, right? As I've mentioned in the in that message that I posted to you all, we have to click this like many times until we reach the point where we can view like the actual assignment itself. I believe it was like 13 times before we actually see it. So we're going to hit next once, twice, 3, 4, 5.
Wait, what happened to like all the we're skipping over a
7,
lot of stuff. Are we gonna come
8,
back to it?
9, 10, 11, 12, and 13. Emmett, yes, we are going to go back to it. The reason why we skipped over so many of those things is because originally, like, no one planned the pandemic, right? So when the original course was designed between Mr. Rubel and I, and Mr. Drost, we decided that we would go into circle geometry directly after talking about similarity, just because it flows pretty nicely. The only thing is Khan Academy, their curriculum, they decided, I mean, in their planning and coordination, they have their circle geometry happen towards the end of the curriculum. So it's a little out of order from what what the teachers at lab had decided. So that's the reason for the disorganization. Okay, but we're gonna go with what the teachers at lab originally had decided. So that's why we skipped over some of those things.
Right. Well, I've calculated the amount of problems, and if you do at least 6 problems a day, then you can finish in about a month.
Yeah. Okay. So we're actually going to click next one more time. Okay, to get to arc measure right here. Okay, so we're going to click on this. Okay, and we're going to go through talking about this. I'm going to give you guys some notes, okay, just to so that we can you know, so that we can accomplish this and finish this up. Okay, so we're looking at this problem right here. Okay, everyone have this displayed in there in your own personal tab?
No. It's all
Yep.
I'm
Yes?
just doing it right now. Oh, and morning, Mr.
I'll
Chair.
give you a second. Okay.
Morning, Mr. Chair.
Good morning, Michael.
wait, Mr. Chan, what's it called?
What's what called?
The exercise.
This is
Arc
arc measure. And you'll have to click next like 14 times before you see it.
Got it.
Arc measure.
Got it.
Cool?
Mhm.
Yes.
All right. So, just to be clear here, this question is asking for what is the arc measure of AB on circle P in degrees? Okay. And so what this is saying, okay, when you're asked to find out what the arc measure is, okay, I'm gonna switch over to my tablet now. Okay, so just give me a second. Okay. So when we're talking about circles and circle geometry, we need to be clear on some of the terminologies. Okay, this stuff is not you. This stuff is calculus. So I'm going to erase all this. Okay, so we're here now. Okay. Scroll up here. There you go. All right. So let's just be clear on some of the terminology so that we're all like communicating in the same manner and we have the right vocabulary for all this. Okay. And actually, you're going to see something similar on in the notes that you're going to take from the videos that I've prescribed in this week's assignments. Okay. So you're going to see a little bit of repetition, but that's okay because, you know, it's always good to see something multiple times, okay? So we have a circle, right? And in a circle, okay, at every circle there's a center, okay? All of the points that are on the circle, let's say I have these 2 points right here. I have A and I have B, okay? These 2 points, are they the same distance away from the center?
Yes.
They are, right? They're the same distance away from the center. So I'm going to call the center here O, okay? They're the same distance away from the center. So, and that's actually how we define what a circle is, okay? All the points on a circle, okay, they're the same distance away from the center. I'm just going to write that down over here, okay? So all points that are equal in distance from a common point. Let's just think about that, right? So think of the condition that satisfies this, right? All points that are equal in distance from a common point. The only like thing that satisfies this description is a circle, right? Because all the points that are here, okay, they're going to be equal in distance. The and we call this equal in distance, right? There's a name for this, okay? This thing that's equal in distance, we call that r, right? So r here is the radius of the circle. and you know this, okay? You walked into office hours today already knowing that fact, okay? There's some other terminologies, okay? So we can talk about distances in a circle, okay? I mean, from any point on a circle to a center. We can also talk about distances going from one point on the circle to another, okay? Which here I'm going to call C and D. Okay, so the length of CD, okay? So the length of CD, okay, is drawn in the circle, okay, drawn on the circle. Okay, and this length right here is what we call a chord. Okay, so you can pretty much draw as many different kinds of chords as you like. Okay, but my question to you, okay, knowing the name of this line that I just drew now, okay, what is the largest? What is the longest, I should say, not largest, but the longest chord in a circle?
The diameter.
Everyone agree, disagree with Emmett's statement? Kira, do you agree?
Yeah.
Right? So the longest chord in a circle is a diameter, right? So it's a diameter. Okay. All right. There's something else that we can also talk about, and that is this idea right here. Okay. So this, so angle AOB, okay, angle AOB, okay, is what we refer to as a central angle. Angle AOB is what we refer to as a central angle. Okay, and a central angle, there are actually two ways of thinking about this. Okay, do you guys know what I mean by two ways of thinking about this? There's actually two different angle AOBs here. Can you guys think of understand why?
The arc one, I think.
So again, let me reiterate the question. There's actually two different angle AOBs. How is it that there are two different angle AOBs?
Because like the circle's curve is also an angle of some sort.
It's not because of it's not because that the circle is curved, right? It actually has to do with something a little. It requires you to visualize a little more. So you know how I have
The angle on the outside.
So say that again.
The angle on the outside.
That's it. Yeah, it just requires you to think about it. So look, we can talk about angle AOB, okay, as it pertains to this angle over here. We can also talk about angle AOB as it pertains to this angle over here. You see what I'm saying? Right? It's still technically angle AOB, is it not?
Yeah.
Right? So angle AOB, okay, is what we refer to as a central angle. And technically, okay, angle AOB, you know, we can talk about the major or the minor, okay? So there's a major versus a minor. Okay, we can talk about the larger angle AOB versus the smaller angle AOB. A lot. So sometimes it's important for if you're writing a problem, to let the reader know which specific angle that you're referring to. Are you referring to the major angle or are you referring to the minor angle? Okay, and and the types of examples that you're going to see, the writer of the problem should specify, okay, which angle that they are referring to. And if it's not clear, then you should, raise the question, okay, as to whether or not the intention is major or minor. Okay, and then we can talk about something called an arc measure, okay? Okay, and this is a new symbol right here. You see this like curvy looking thing, right?
Yeah.
That I drew just now. So this guy right here, that curvy looking thing, okay, is describing the arc, okay? So this is referring to the arc measure. So this is referring to arc measure. Whoops. So the arc measure, okay, we can actually talk about the arc measure measured in two different ways, okay? There's something called radians, and then there's something else called degrees, okay? And we all know what a degree measure is, right? In a circle, how many degrees are there?
360.
There's 360 degrees in a circle, right? So we can talk about the arc measure in terms of degrees, okay? Arc measure can be referred to in degrees. Can be measured in degrees. Or there's something else, okay? If you think about an arc measure, okay, when I say arc measure, I mean this like physical thing that I'm highlighting in blue, right? We're talking about that. So instead of it being measured in degrees, there's something that we call arc length, okay, or a radian measure, okay, or radian measure. And this concept of what a radian is, okay, we're going to talk about this at a later point, okay? I don't believe the discussion of this idea is embedded in this exercise, but if it is, I'll explain further, okay? So again, just so that we're clear with the terminologies, okay? So that AB there, okay, is described as an arc measure, okay? And then AOB here is described as a central angle, okay? And similarly, okay, if you think about AB, okay, arc AB, you can think of arc AB as in a very similar manner in terms of major and minor, right? So what I've highlighted right now in blue, in this diagram right here, right? Would that be a major arc or a minor arc? That would be a minor because that's a smaller one, right? So anyway, let's just go with these two notes for the moment, okay? And we're gonna take a look at the exercise right now, okay? Oh, there's one more thing I forgot. So so all this other concept is all. Oops. All arc measures in a circle add to how much?
360.
360.
360. That's right. All arc measures in a circle will add to 360. Okay.
Mr. Chan, would
And then
CD
similarly,
also be a chord?
say that again. I'm sorry.
Well, I mean, not chord. Would CD also be an arc?
So CD. So it depends on what you're saying. So if you notice the symbol right here, right, directly above CD, that's a straight line that I drew, right? If I were to write it like this, okay, then that's signifying to you, oh, Mr. Chan is not talking about the chord. Mr. Chan is talking about the arc. Does that make sense?
80 degrees then, right?
Say that again.
It would be 180 degrees CD, and then you'd base it off of.
So CD, arc CD would not be 180 degrees. No. So give
No,
me a
but
second.
like CD, no, CD itself.
You're talking about the angle measure for straight line?
Yeah, it's 180. And
Sure.
what would,
Yes.
there's no minor or major there, right? What would you do?
For arc CD?
And now, I mean, they're just both 180, so there's no minor or major for the 180 degree line.
So when we talk about a chord, we don't normally talk about like the angle, but we can talk about the arc that the chord intercepts. Okay, so we can certainly talk about the arc that chord CD intercept, which is this guy that I'm highlighting in blue. We can talk about that angle measure. That angle measure there is not 180 actually. Okay, that angle there, it's something else. And as a matter of fact, it has to be less than 180. So let me finish what I'm going to say over here, because there's one other concept. So before over here, I said all arc measures, okay, in a circle add to 360. All central angles in a circle add to, one more time, what is that?
360.
Also 360, right? Kelvin, Kian, Michael, you're okay. You guys are okay with this?
Yeah, I'm okay with this. Yeah.
Okay, so all the angles inside of a circle, they add up to 360. Okay. The thing is, okay, if you think about it, okay, right now, I'm going to draw another circle over here. Okay. And wait a minute. If I have, let's say, something like this, okay, where this is a right angle over here, okay. So right now, the central angle, let's call this A, B, and C, right? So the central angle ABC is equal to 90 degrees. Clear?
Mm-hmm.
Right? What would be the minor arc AC?
90.
It too would be 90, right? Kelvin, are you guys okay with this?
I think
Is
I'm
anything
okay with
from the central just the same?
Are you guys clear with that idea that was just brought across right now? So the central angle and the arc measure, right? What's the conclusion then? Central angle and the arc measure.
From the central,
Yeah.
it's the same.
Right. The central angle and the arc measure of the circle, okay, they are, what is it again?
They add up to 180.
So all arc measures add up to 360, and all add up to 360. But what I'm trying to get at right now is central angle, okay, is it equal? Is it not equal to the arc measure? Guys?
It's equal. It's equal.
It's equal. That's what I'm trying to get across, okay? So central angle and the arc measure, they are the same, okay? This idea is important. The central angle and the arc measure itself, they are the same, okay? All right. Which brings me to the next point, which is what Emmett had brought up about like chord CD from the diagram from above. So if you think about this, okay, what is the longest chord inside of a circle again?
The diameter.
It's a diameter, right? The longest chord in a circle is a diameter. This is, again, we're seeing some consistencies, okay, that happen in math all the time, okay? When something's defined in one sense, okay, but looked at in a different perspective, they all have to be aligned. So if you look at this, okay, right now, this half right here that I'm highlighting in blue, right? What's the arc measure?
180.
The arc measure is 180. Look at that. The arc measure here is 180. I'm going to call this, I don't know, MIC, okay? I'm going to call that MIC. So arc MC, okay, is equal to 180. But what about the chord? I mean, not chord. What about the angle MIC? Isn't that 180 also?
Yeah.
Right? That's also 180. So going back to the question that Emmett had asked, okay, about what CD was from the diagram above. Everyone have this right now before I move it? Do we all have this before I move it? Yes?
Yeah.
Okay. I want to go back over here, right, to this diagram that I drew. Does this chord CD pass through the center?
No.
It doesn't. Because it doesn't pass through the center, what can we conclude about arc CD? Is it going to be greater than 180, less than 180, or
Less.
equal to 180?
Less.
Kira, do you agree?
Yeah, I agree. It would be less.
Okay. How do you know, Kira? Can you maybe articulate a little more?
So because it isn't, I forgot what the word was, but because it isn't, it's not the diameter. It'll be less than.
That's right, because it's not the diameter. CD is not the diameter. The length of CD is going to be shorter than the diameter, right? So therefore, the angle that we're dealing with here, that's intercepted by that is the arc measure of CD. It has to be less than 180. Anyway, getting back to this whole concept, okay? I think we are ready to work on the assignment now, okay? I'm going to get back over here to the laptop, and I'm going to present screen or resume presenting screen on the laptop.
No, you're still doing your tablet.
Yeah, I know. All right, here we are. Going back. So we are looking at this guy right here, okay? So notice, okay, in this problem now, it's asking for arc AB, okay? So, guys, is this clear that we're talking about the minor or the major?
The major angle.
Guys, what do you think?
And
In
The minor. They're asking for
Not the
AB.
minor. Because
Oh.
if it was major, notice there's a point here, there's a point C here, right?
Mm-hmm.
If they wanted to talk, if they wanted you to find the major arc, okay, they would have said arc A, C, E. They would have included the point in here, but they did not. Okay, and that was intentional. So it's only this guy right there. So what's the central angle right now? Okay, for angle AFB, APB. Is it 286 or is it something, or is it smaller?
It's smaller. It's 74 degrees.
It's smaller. It's 54 degrees. Wait.
It's 74. I subtracted
74 degrees. Okay. So so therefore, what has to be the arc measure for AB, Kelvin?
74.
Thank you, guys. But okay, are you clear with that?
Yeah.
All right, it's 74. Okay, this guy right here is 74. Okay, that's all it is. Okay. All right. All right, so we have a couple more. The diagram's getting a little more complicated, okay? What is the arc measure of ADE in degrees? ADE. Notice now, okay, they are specifying, okay, like indicating like which angle we're looking at here. We're looking at ADE. Okay, what is the measure of arc ADE in degrees?
Wait, can't we do 63 plus x plus 90 since angle ADE is part of
Um,
angle BD, so technically that would be 180.
Is it
ADE
90?
is 90 because it's already lining up with the diameter.
Hold on. I am actually. Wait. I'm sorry. In the figure below, BD and EC are diameters of circle P. Okay, so BD and EC, they are diameters. Okay, what is arc measure of ADE in degrees? A, D, and then go back to E.
Wait,
I'm a little
hang-
confused about the notation here.
I think what they're asking is what the angle measure is because
Say that again, I'm sorry?
we already know that BD is the diameter. So what we can use for that, we know that from BPA, that's a right angle. So we could just use that to fix the diameter. So technically, it's 90.
Right, but my confusion is oh no. I'm sorry. Here, let me elaborate. So when we talk about angle AD, we're talking about A going all the way around D.
Oh,
You see what I'm saying? Look at my mouse pointer again. Again, we start from A, we go all the way around to D, and then we go to E. What is that arc? What is major arc? Okay, as a result. So what can we say about angle APB here? What is that angle?
that's 90.
That's 90. Michael, do you agree?
Yes.
Okay, what is angle BPC? What is angle BPC? And do you know?
Minor, but we don't know the exact number. But
We
what
actually
that-
do, because if you look at this,
Um,
right, EC and BD
that's also
are diameters, right? So which means they are straight lines. What has to
63.
do with
It's
this
also
angle over
63.
here? Kira, can you say it?
63.
How do you know that?
Because vertical angles are congruent. Those two are vertical angles.
Excellent. So this angle over here is 63 degrees. Okay. Can you tell us what is angle EDC? What is the arc measure of EDC?
EDC is just 180.
Guys agree?
Yep.
Okay.
Yeah.
So wait. So our task is to find out what ADE is, right? So A all the way around to D, all the way to E. So how do we do that? So wait a minute.
You
90,
can just,
63, Emmett, yes, tell us.
I mean, all you need to do is just add up 180, 63, and 90, and then you'll have it.
That's it. So we're going to add 90, 63, and 180. Okay. And Emmett, what would that be?
333.
333. So I'm going to put that in there.
Okay.
All right. We're going to do it again. In the figure below, AD and CE are diameters of circle P. AD and CE are diameters of circle P. What is the arc of AB? And again, we're talking about the minor arc in this case, right? Arc AB.
Well, according to Kira's solution, we could just use the vertical angles are congruent because from the opposite of 90 to 93 degrees,
Yep.
the opposite of that is also 93. So if we
That's
combine
right.
those two together and subtract 360 by that, then we
Angles
can figure out
APE.
what both CPD is along with APE. And then we just divide it by 2.
Mm-hmm.
What?
So you
Little-
subtract
little-
38
I like
from
the train
93.
of thought. We do need to use vertical angles, but we actually do not need to apply 360 or 180 in this case. Because and do you see what I'm pointing at right now? These two angles together. These two
They
angles.
equal 93 degrees, and then 33 minus 93 equals 55.
Yeah, the answer is 55.
Right. So so these two added together must add up to 93. You see that, Ken?
Mhm.
Okay. So these two added together will equal to 93. Calvin, can you tell us what is 93 minus 38?
Hold on.
55, right? Yeah.
Yeah.
Get used to the circle.
Get used to the circle.
Yeah. I already finished it, but yeah, so I'm telling you, there's another one with the same one.
Wait, is this the same question?
No, this time it's all the way around from A to B. The other
Oh,
way.
this was AE.
And now it's 38 instead of 33.
No,
Okay.
it was always that way.
So actually, we have everything. If you think about it, this angle in here, what I'm pointing at right now, Kelvin, what was that angle again?
55.
All you have to do is just subtract. All you have to do is just subtract 360 by 55, and then there's our answer.
Yeah, that's all it
Easy.
is. Thank you. Kelvin.
305.
So all we could do is just take 360 and minus 55, and we'll get everything going the other way around. And Kian, what is the answer to that?
305.
305. There we go. Okay, and that completes that assignment for today. Okay, I
Wait,
am
can you
going.
tell me what energy points are? I've never understood it.
I am
So
not.
those points for
I don't know. They just say
Academy.
that you get
like a
the
background
energy
for your character,
points
or just
and
like
then
finding like a new avatar or something.
Say that one more time.
So the points are for finding a custom avatar and a custom background that they give you. So that's
And why,
what they end.
and why on God's Earth do I need a custom logo for Khan Academy?
How the hell should I know?
Exactly.
Just to look good.
Hey guys,
Cool.
you know what? Wait. You better teach.
Don't you want to speak up?
When I find out how to make a custom logo on Khan Academy, I'm 100% gonna make my my custom logo anime Kim Yo Jong drawing.
Hey Ricardo, I didn't realize you were here. You came in. When did you come in?
Never said anything.
I came in a while ago, actually.
You came in a while ago.
a while.
Just
as well.
Okay. All right. I want to stop recording. Okay. So, you guys have any questions for me?
Not really.
Not really, right?
Still recording.
So Kira, this has generally been our format. We during office hours we go through the assignment together, and then afterwards,
Yeah.
we'll pretty much be done with the assignment for today. Okay, that's geometry related. Okay.
It's still
Yeah.
recording.
What was that?
Still recording. It's
I'm
still
still recording?
recording. Yeah.
Oh, okay. Stop recording.